Molecular geometry, VSEPR theory, 4 electron domain molecules. In this tutorial, we will be looking at 4 electron domain molecules, tetrahedral geometry. We'll be looking at a methane example, an ammonia example, and a water example. 4 electron domain molecules, tetrahedral geometry. The first example that we're going to look at is methane, CH4. Methane has 4 electron domains, 4 single bonds around the central carbon atom. So 1, 2, 3, 4. 109.5 bond angles exist between each carbon to hydrogen bond. No non-bonding electron pairs on the carbon atom in the methane molecule. The electron geometry is tetrahedral, and the molecular geometry is also tetrahedral. Ammonia, NH3. Ammonia has 4 electron domains around the central nitrogen atom. 3 of the electron domains are single bonds between the nitrogen and the terminal hydrogen atoms. So 1, 2, 3. 1 electron domain is a non-bonding electron pair on the central nitrogen atom. So right here is our 4th electron domain. The bond angle in NH3 is approximately 107.8, which is slightly less than the ideal 109.5 degree bond angle associated with tetrahedral electron geometry. This slight compression of the bond angle can be explained by the non-bonding electron pair on the central nitrogen atom exerting a greater repulsive force on the 3 bonding electron domains to the 3 hydrogen atoms. So this lone pair pushes down on each one of these shared electron pairs, making these bond angles slightly compressed. The electron geometry is tetrahedral, and the molecular geometry is trigonal pyramidal. The ammonia molecule is a pyramid with a triangle base. Water, H2O. Water has 4 electron domains around the central oxygen atom. 2 of the electron domains are single bonds between oxygen and the terminal hydrogen atoms. So 1, 2. 2 electron domains are non-bonding electron pairs on the central oxygen atom. So 1, 2. The bond angle in water is approximately 104.5, which is slightly less than the ideal 109.5 bond angle associated with the tetrahedral electron geometry. This slight compression of the bond angle can be explained by the 2 non-bonding electron pairs on the central oxygen atom exerting a greater repulsive force on the 2 bonding electron domains to the 2 hydrogen atoms. So the electron geometry is tetrahedral, but the molecular geometry is bent. So this bond angle right here is 104.5 because these lone pairs right here and back here are compressing this bond angle. So what did you learn? We talked about 4 electron domain molecules with tetrahedral geometries, and then we looked at methane, ammonia, and water as examples. Need more help? Feel free to contact me. Have a great day.